Hello student, welcome to my channel Learn Physics. Today I will be discussing the solution of JEE Main 25th January second half, that is 3 p.m. to 5 p.m. This discussion will be extremely helpful for you to tackle the MCQ and short question in your next examination such as NEET, JEE Main second stage and JEE Advanced. If this discussion is beneficial for you, please like, share, and comment on the video. Okay, now let's start. Now, question number one. Given below are two statements. The statement one, the stopping potential in photoelectric effect does not depend on power of light source. Okay, the stopping potential only depends on this is the frequency of radiation and nature of metal surface, that is work function. So this is the false statement. Okay, statement 2, for a given metal the maximum kinetic energy of photoelectron depends on the wavelength of incident radiation. Look at this is the correct option. Okay, so this is the correct and this is the false. Now look at this option 4. Statement 1 is incorrect, but statement 2 is correct. Okay. Now question number 2. A point charge of 10 microcoulomb is placed at the origin. At what locations or on the x-axis should a point charge of 10 microcoulomb placed so that the electric field is zero at x equals to 10 centimeter on the x-axis? Now look at this. This is the figure. Now this is the origin. So here 10 microcoulomb charge is placed here. The neutral point. This is the x equals to 2 centimeter. No problem. Suppose another charge is placed at a distance of, this is the r distance from the origin. Okay, so distance from this is the r by 2. Okay, this is the this distance. As electric field at this point is 0, so look at this is the 10 microcoulomb divided by this is the 0.02 whole square. This equal to k into this equal to k into this is the 40 microcoulomb, this divided by this is the r minus 2 divided by 100 whole square. Okay, now 0 0 cancel out, microcoulomb micro cancel out, k cancel out. So this can be written as this is the 1 by 0.02 whole square, this equal to this is the 2 by this is the r minus 2 by 100, this is the whole square. No problem. So look at this is the now look at this is the 1 by 0.02 into this is the 2 by this is the r minus 2 by 100. Okay, so look at this here from this condition, from this. Now look at this. Now look at this. From this we can write as this is the r minus 2. This is the 200 into 0.02. Okay. So this is the 4. Therefore r equal to 6. Therefore position of, so this is the position of charge from the origin is x equals to 6 centimeter. Okay. Option 1 is correct. Now look at this. There is a matching type question. List A, list. Look at this troposphere. This is the lowest layer of Earth atmosphere. So look at this. A is the 3. Okay, this is the 10 kilometer over the Earth surface. Okay. Now E part of stratosphere. Now F2 part of thermosphere. You know thermosphere is light above the stratosphere. So look at this. Look at this. C is the, this is the 2. 300 kilometer of the Earth's surface. Now, D part of stratosphere, look at this, D part of stratosphere lies below the E part of stratosphere. So look at this is the 100 kilometer and this is the 65 to 75 kilometer. So look at this is the D, okay, and finally this is the B. Therefore, look at this A3, B4. Look at this A3, B4, C2, and D1. Okay. So option 2 is correct. Okay. Now question number 4. Consider a block, consider a block kept on an inclined plane, inclined at an angle 45 degree. Look at this angle 45 degree. Okay. As shown in the figure. If the force required to just push it up inclined plane is 2 times the force required to just prevent from sliding down. Now, the minimum force required to slide down minimum force required to prevent slide down is equal to mg into this is the sin theta minus mu cos theta. That is resultant force in the downward direction. Now minimum force required to move up the plane, this is the F2, this equal to this is the mg into sin theta plus mu cos theta. Okay. Now, from given condition, F2 is the twice of F1. So, twice of F1, this equal to F2. Okay. So, look at this is the mg, here sin theta plus mu cos theta. This equal to 2 into this is the mg into sin theta minus mu cos theta. Okay. Now, mg cancel out. Okay. Now, look at this is the mu cos theta into 2. So look at this, and this is the mu cos theta. So here 3 mu cos theta, this equal to this is the sin theta, because 2 sin theta minus sin theta equal to sin theta. Therefore mu equal to this is the 1/3 tan theta. Now theta equal to 45 degree. So this is the 1/3 tan 45 degree. This equal to 1. So this is the 1/3. Now option C is correct. Okay. Next question. Now question number 5. For a moving coil galvanometer, the deflection in the coil is 0.05 radian. That is theta equal to 0.05. Okay. When a current of 10 milliampere is passed through it, now current I equal to this is the 10 into 10 to the power minus 3 ampere. Okay. If the torsional constant of the suspension wire is 4 into 10 to the power minus 5 Newton. Now C equal to this is the 4 into 10 to the power minus 5 to Newton meter per radian. Okay. No problem. The magnetic field B equal to, look at this, B equal to this is the 0.01 Tesla. The number of turn capital N, this equal to 200. Now area of the each turn. Now area of each turn. Look at this. You know C theta, this is the B na. Okay. Now C is equal to, look at this is the 4 into 10 to the power minus 5. Theta is the 0.05, B is equal to 0.01, I is the 10 to the power minus 2 into N is the 200. You have to calculate. Okay. Now look at this is the 20. Now this into this, so this is the point. Look at this is the 0.2 into 10 to the power minus 5. Now look at this is the 10 to the power minus 4 into this is the 200 into A. Therefore, look at this is the A equal to this is the 0.2 into 10 to the power minus 5 divided by, look at this is the 2 into 10 to the power minus 2. So look at this is the 10 to the power minus 4. Therefore, area of each turn, this is the 1 centimeter square. Look at this, option 1 is correct. Okay. Now question number 6. A body of mass taken from the earth surface to the height h equal to twice the radius of the earth, the increase in potential energy. Now, increase in potential energy U equal to delta U equal to, this is the U2 minus U1. What is U2? Look at this. This is the GMM with negative sign divided by R plus H. Now, H equal to, this is the 2R minus, this is now potential minus potential energy on the earth surface, this equal to gmm by r. Okay, and this is the negative side, so you get, look at this, this is the gmm. Okay, this is the 1 by r minus 1 by 3r, no problem. Now look at this, this is the gmm, this is the 2 by, this is the 3r. Now you know Gm equal to, this is the Gr square. So look at this, this is the 2 by 3 m Gr square divided by 3r. Now these are and this cancel out. So this is the 2 by 3 mgr. Okay, no problem. Next, I uploaded the one shot video of NCERT physics of almost each chapter. If you watch this one shot videos, this MCQ becomes common for you. So you can watch first this and then solve this numerical. You can easily solve all 30 questions. Okay, no problem. Next. Now question number 7. The resistance of a wire is 5 ohm. Its new resistance in ohm if it stretched 5 times of its initial length. Now for stretching, resistance are proportional to square of length, that is L square. So look at this, R2 by R1, this equals to L2 by L1 whole square. No problem. Now L2 by L1, this is the 5. So this is the 5 square. Now R1 is equal to, this is the 5 ohm. Therefore R2 equal to, this is the 25 into 5. So this is the 1 to 5 ohm. Okay. Now option 2 is correct. Okay. Next. Now question 9. There is a matching type question. List 1, list 2. Now Gauss law of electrostatic. That is, look at this, the surface integral of electric field equal to Q by epsilon naught. Now look at this. This is the 4. Now B, Faraday's law. Look at this Faraday's law. This is the E vector dot dl vector. Look at this. This is the B. Okay. Now this is the Gauss law of magnetism. Look at this B vector dot A vector equal to 0. So this is the C. Now this is the Ampere Maxwell law. This is the D. So look at this A4. Look at this A4. This is the option 1 correct. Okay. Next, I have already uploaded the solution of 24th January first half and second half, 25th January first half, and 30th January second half. These videos will be extremely beneficial for your next examination, that is NEET, Main or JEE Advanced. Okay. Now next. Now question number 9. A light rays from an object have been reflected towards the observer from a standard flat mirror. The image is observed by the observer. Look at this. This is the erect, not real. This is the virtual. Smaller in size. No, 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 no. Laterally inverted. So look at this. B and D are correct. Okay. So look at this. Option 1 is correct. Okay. Now, question number 10. The energy level of an atom as shown in figure. Look at this. This is the zero energy. This is the minus 2.2 electron volt. This is the minus 3.2 electron volt. And this is the 10 electron volt. Okay. Now, which one of the transition will result the emission of photon of wavelength 1 to 4.1 nanometer? Now look at this. You know energy E equal to, this is the 1241 EV nanometer divided by wavelength, that is here. Look at this. This is the 1 to 4.1. This is the 1 to 4.1 nanometer. So look at this. You can get, this is the 10 electron volt. Now which transition gives this 10 electron volt? Look at this. D transition gives 10 electron volt energy. So look at this. Option D is correct. Okay. Number 11. The statement type question. When a SI sample is doped with boron, it becomes a p-type, and when doped by arsenic, it becomes n-type. Look at this, boron is trivalent. So when silicon is doped with boron, it becomes p-type, and arsenic is the pentavalent. So this becomes n-type. So this statement is correct. Now statement 2. When such p-type and n-type semiconductor are fused to make a junction, current will automatically flow, which can be detected with a externally connected ammeter. No, the p-n junction is not formed by fusing separate p-type and n-type semiconductor. So this statement is wrong. Therefore, statement 1 is correct and statement 2 is incorrect. Look at this. This is option 1. Now, question 12. Every planet revolves around the sun in an elliptical orbit. Look at this. The force acting on the planet is inversely proportional to the square of the distance from the sun. Yes, it is the correct statement. Now, force acting on the planet is inversely proportional to the product of the masses of the planet and the sun. Okay, this is the wrong statement. This is the directly proportionate. So, this is the wrong statement. The centripetal force acting on the planet is directed away from the sun. No, 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 no. It is always directed towards the sun. The square of the time period of revolution a planet around the sun directly proportional to the semi-major axis of the orbit. Okay, this is correct statement. So look at this statement, A and D are correct. Look at this, option 4 is correct. Okay, next. Now question number 13. The graph between the two temperature scale P and Q as shown in figure. Between the upper fixed point and lower fixed point, there are 150 equal divisions of scale P and 100 divisions of scale Q. The relationship between the conversion between the two scales is given by. Look at this P scale, look at this is the 180. Now it has 150 division. Okay, so look at this must be 30. So lower fixed point of this scale is this the 30. Now look at this is the 100, as it has only 100 division. So look at this scale lower fixed point 0. Therefore look at this, the temperature, this is the TQ. Now temperature, this is the TP minus lower fixed point, this is the 30, divided by fundamental interval. So this is the 150. Now look at this TQ, temperature in the Q scale minus lower fixed point divided by fundamental interval. Now look at this, option 4 is correct. Okay. Now question number 14. According to the law of equipartition of energy, the molar specific heat of a diatomic gas at a constant volume where molecule has one additional vibrational mode. For a diatomic molecule, for vibrational mode, there are 2 degrees of freedom, and The diatomic molecule also has 5 degrees of freedom. This is the 3 translational, 2 rotational, and here 2 vibrational. So there are 7 degrees of freedom. So look at this. CV is equal to, this is the half FR. Therefore, this is the half into 7 into R. Look at this. Option 3 is correct. Okay. Now question number 15. Two objects are projected with same velocity u, however at different angle alpha and beta with the horizontal, where alpha plus beta is 90 degree. The ratio of horizontal range for the first object and second object. For angle of projection theta, and this is the 90 degree minus theta, the horizontal range are equal. Therefore, look at this. Here alpha plus beta is equal to 90 degree. Here alpha plus beta 90 degree. So their range are equal. Therefore, R1 is to R2. This is the 1 is to 1. Now option 1 is correct. Okay. I have already uploaded the one shot video of motion in 2 dimensions. This is the NCERT one shot video. This type of question is easy for you if you watch this video. Okay. Now there is a matching type question, list 1 and list 2. This question is from thermodynamics. Okay. And this is a very easy type question. Now look at this. Isothermal process. Work done by the gas decreases internally. No. In isothermal process, the internal energy 0 as delta D 0. So internal energy 0. So this is the A. Now adiabatic process. The work done by the decrease in internal energy. Yes, as delta Q equal to 0. So work is done in expense of internal energy. So look at this. This is the B. Okay. Now isochoric process. No work is done because here delta V equal to 0. So this is the D. Now look at this A1, B. Now look at this A2. Look at this A2, B1 and D4. Look at this D4. So look at this. This is the 4 RA. Okay. Next. Now look at this. There are another matching type question. Young modulus, the dimension of Young modulus, this is the pressure. Pressure means this is the mLT minus 1. So look at this. Now pressure means, now the dimension of pressure, this is the mL minus 1, T minus 2. So this is the A. Now coefficient of viscosity, dimension is mL minus 1, T minus 1. So this is the B. Now Planck's constant, this is the angular momentum. So this is the C. And finally work function, this is the energy. So this is the D. Now look at this A3. Look at this A3. This option A3, B1, C2. Now look at this A1. Now look at this A3, B1, C2 and D4. So look at this option A1. So option 1 is correct. Okay. Now question number 18. A wire of length is moving with velocity 8 meter per second at right angles to a magnetic field of 2 Tesla. The magnitude of induced EMF between the ends of the wire will be. Now motional EMF E equals to, this is the BLV. Now what is B? B is the 2 Tesla. What is L? 1 meter. B is the 8. So look at this. This is the 16 volt. Now this is the option 4 is correct. Okay. Now question number 19. A particle executes simple harmonic motion between x equals to minus a and x equals to a. If time taken by the particle to go from x equals to 0 to x equals to a by 2 is 2 seconds, and time taken by the particle to go from a by 2 to a. Now look at this. This is the mean position. This is the x equals to 0. If time taken by to reach from x equals to 0 to x equals to a is this is the t by 12 and this is the t by 6. So look at this. If this is the 2 second, this is obviously 4 second. Okay. Now look at this. Option 2 is correct. Okay. Next. Now look at this question number 20. The distance traveled by a particle related to x equals to 40 square. The velocity of the particle at t equal to 5 seconds. Now look at this. If you differentiate x with respect to t, you get velocity. So v equal to this is the dx by dt. So this is the 4 into t. Now t equal to 5. So this is the 20 meter per second is the correct option. Look at this 21. A solid sphere of mass 5 kg and a disc of mass 4 kg have same radius. The ratio of moment of inertia of the disc about tangent in its plane to the moment of inertia of the sphere about tangent will be. Now look at this, the moment of inertia. Now look at this, this is a disc. Okay. The moment of inertia about the tangent in its plane. Look at this, this is the half, this is the 1 by 4 mr square plus this is the mr square. So look at this, this is the 5 by 4 mr square. Now mass of the disc is 4 kg. So this is the 5 by 4 into 4r square. So this is the 5r square. Okay. Now moment of inertia of the sphere about its tangent. Look at this. This is the tangent. So moment of inertia of the sphere. This is the 2 by 5 mr square plus this is the mr square. So look at this. This is the 7 by 5 mr square. Okay. So look at this. This is the 7 by 5 into 5 r square. So look at it, this. So this is the 7 r square. Now look at this, the ratio become this is the 5 r square divided by 7 r square. So look at this cancel out. So here this is the x by 7, therefore x equals to 5. Okay. Now 22. A nucleus disintegrates into smaller parts which have their velocities ratio 3 is to 2. The ratio of their nuclear size will be x by 3 1/3. Look at this, if A1 and A2 be their mass number, so look at this is the A1 into 3V equal to this is the A2 into 2V. Okay. So look at this V and V cancel out. So look at this is the A1 by A2. This is the 2 by 3. Now look at this is the 2 by now radius r is equal to this is the a1 by a2, this to the power 1/3. So look at this is the 2 by 3 to the power 1/3. If this equal to this, look at this, so x obviously 2. So x equals to 2. Okay, next. Now question number 23. An object is placed on the principal axis of a convex lens of focal length 10 centimeter. Look at this here, focal length f is equal to 10 centimeter. Okay, a plane mirror is placed on the other side of the lens at a distance of 20 centimeter. Look at this is the 20 centimeter. Okay, no problem. The image produced by the plane mirror is 5 centimeter inside the mirror. Okay, the image formed by the plane mirror is 5 centimeter inside the mirror. Look at this. This is the image formed by the plane mirror. Okay, if this is the 5 centimeter, so this also 5 centimeter. So this image, look at this image is formed by the convex lens. Now this is the 15 centimeter from the convex lens. Now focal length 10 centimeter, image distance 15 centimeter. So object distance, look at this here, u equal to question mark. Therefore 1 by v minus this is the 1 by u equal to 1 by f. Now look at this is the 1 by 15 minus this is the 1 by u equals to 1 by 10. Therefore minus 1 by u, this is the 1 by 10 minus 1 by 15. So this is the 1 by 30. So u equal to this is the minus 30. Okay. So distance of the object from the lens is equal to 30 centimeter. Okay. Next problem. If you watch my one shot video of ray optics, this type of numerical is very easy for you, and you can solve this numerical only 15 to 20 seconds only. Okay. Look at these two long parallel wires carrying a current 8 ampere and 5 ampere in opposite directions are placed at a distance of 7 centimeter from each other. A point P equidistant from the both the wires such that the line joining the point P to the wires is perpendicular to each other. The magnitude of magnetic field at the point P. Look at this. Suppose this is a parallel conductor. Look at this. This carries a current inwardly, and this conductor carrying a current outwardly. No problem. Now, the distance of separation between them, this is the 7 centimeter. Okay. Now, look at this. Suppose P is a point. Okay. The line joining from this conductor to P and again from this conductor to P makes an angle 90 degree. Okay. Look at this angle 90 degree. Look at this, the magnetic field due to inward current. Look at this, the magnetic field due to this inward current is directed along this direction. Okay. And magnetic field due to this outward current is directed along this direction. So these two magnetic field B1 and B2 are perpendicular to each other. Now we have to calculate the resultant magnetic field B equals to this is the root under of B1 square plus this is the B2 square. Okay, no problem. Now we have to calculate the distance of the conductor from the point P. Okay, a perpendicular line is drawn from, look at this, P to the conductor. Okay, look at this is the perpendicular line. Look at this, as this angle 45 degree, the distance from the conductor to the point P is R. So R divided by 7 by 200 meter, this equal to cosec 45 degree. Okay. Now cosec 45 degree equal to root 2. So look at this, R equal to this is the 7 root 2 divided by 200 meter. Okay. So look at this magnetic field B1. This is the mu naught by 4 pi. This is the 2 into I1. I1 means 8 divided by R. R is the 7 root 2 into this is the 200. Okay. Now look at this. This is the 10 to the power minus 7 into 200. So look at this. This is the 10 to the power minus 5. Now root 2 into 2. So this is the root 2 and 7. So this is the point root 2. So look at this. This is equal to this is the 3.2. Okay. Again, in the same way, look at this. B2 equals to this is the mu naught by 4 pi. This is the 2 into 15 into this is the 200 divided by 7 root. So look at this. This equal to this is the, look at this equal to this is, now this equals to 10 to the power minus 5 into this is the, look at this 8 into 3.2. So look at this is the 6.0. Okay. Now look at this, the here answer is something into 10 to the power minus 6. So look at this can be converted as 32 into 10 to the power minus 6. This is the 60 into 10 to the power minus 6. So resultant magnetic field, look at this is the 32 square plus this is the 60 square. Okay. Now under root into 10 to the power minus 6. So look at this, 4 into 17 into 10 to the power minus 6. So look at this, 68 into 10 to the power minus 6 is the magnetic field at the point P. Okay. Next. Now look at this, a spherical drop of liquid split into 100 identical spherical drops. If Ui be the initial surface energy of the original drop and UF be the total surface energy of the remaining drops. Okay, you have to calculate UF by UI. Okay, now look at now UF by UI equals to 10 by x. You have to calculate the x. Now look at this, the surface energy UI, this is the 4 pi r square into s. Now surface energy of the final, look at this is the 4 pi small r square into s into 1000. Okay, now look at this, here r is equal to, this is the capital R divided by 1000 to the power 1/3. That is, this is the r by 10. Now if we put 4 pi, this is the r by 10 whole square into s into 1000. So look at this is the 10 into 4 pi r square s. Okay, so look at this, UF by UI, this equal to 10. So this is the 10 by x. So this is the, so x is equal to 1. Now 26. A train blowing whistle of frequency 320 Hz approaches an observer standing on the platform at a speed of 66 meter per second. The frequency observed by the observer. Look at this, when source moving towards the observer, the apparent frequency f dash, this is the v by v minus vs into f. Now look at this is the 330 and this is the 330 minus this is the 66 into f is the, this is the 320 hertz. Now 33 common, 33 into 10 and this is the 33 into this is the 10 minus 2, this is the 320. Now look at this and this cancel out. So this is the 10 by 8 into 320. Okay, look at this is the 40. So apparent frequency is the 400 hertz. Okay. Now question number 27. A body of mass 1 kg collides head-on elastically with a stationary body of mass 3 kg. Okay. After collision, the smaller body reverses in direction of motion and moves with a speed of 2 meter per second, the initial velocity of the smaller body after the collision. Now look at this, you know the velocity v1 of the first body, this is the m1 minus m2 divided by m1 minus m2 into u1. And look at this, as u2 equal to 0, so second term vanishes. Now look at this is the minus 2 meter per second. This equals to mass 1 kg and this is the 3 kg. Look at this is the mass 1 plus 3 and this is the u1. Okay, now look at this and this. If you cancel it, so this is the 2. Therefore, u1 equals to, this is the 4 meter per second. Okay, now look at this, option 4 is correct. Okay, now question number 28. A capacitor has a capacitance of 5 microfarad when its parallel plates are separated by air medium and thickness d. So look at this here, 5 microfarad, this equal to, this is the epsilon naught A by T. Okay. Now a slab of material of dielectric constant 1.5 having area equal to that of the area of the plate and thickness is d by 2 is inserted between the plates. The capacitance of the capacitors. Now look at this. Suppose this is a parallel plate capacitor. Half portion is inserted by the slab of dielectric constant K equal to, this is the 1.5. Now this is the C dash. This is the epsilon naught A divided by, this is the d by 2 by 1.5 plus d by 2, this is the air medium. So look at this here, C dash, this equal to, this is the epsilon naught A by d, this equal to 1 by this is the 1/3 plus this is the 1 by 2. Okay. Now look at this. This is the 5 by 6. So this is the 6 by 5. So this is the 6 by 5 into epsilon naught A by D. So look at this. This is the 6 by 5 into 5. So this is the 6 microfarad. So look at this here. This is the 6 microfarad. Now question number 29. A series LCS circuit is connected to an AC source of 220 volt 50 Hz. The circuit contains a resistance of 80 ohm, inductor of inductance having resistance 70 ohm, and capacitor of capacitance, look at this, 130 ohm. Now power factor of the circuit is, this is the, okay, we have to calculate X. Power factor cos phi, this equals to R by Z. Now here R equals to, this is the 80. Okay, and Z equal to, look at this is the R square plus this is the XC minus XL whole square. Now look at this is the 80 divided by, look at this is the root under of 80 square, and this minus this, so this is the 60 square. So 80 square plus 60 square, so this is the 100 square, so this is the 0.8. So this is the 8 by 10. Now here x by 10. So look at this is the x by 10. Therefore, x is the 8. Okay, next. Now look at this last question number 30. Two cells are connected between point A and B. Look at this is the point A and this is the point B as shown. Cell 1 has EMF 12 volt. Look at this is the 12 volt, and internal resistance, this is the 3 ohm. And cell 2 has, this is the 6 volt and internal resistance 6 ohm. And external resistance R equals to 4 ohm is connected across A and B. The current flowing through R will be. Okay. Now look at this. This is the R. Okay. We have to calculate the current through R. Okay. Now we have to calculate the equivalent internal resistance. Now we have to calculate equivalent EMF and equivalent internal resistance. Now equivalent EMF, this is equal to, this is the 12 by 3 plus this is the 6 by 6 divided by 1 by 3 plus 1 by 6. Look at this is the 4 plus 1, so this is the 5 divided by, this is the 1 by 3, 1 by 6, so this is the half. So look at this is the 10 volt is the equivalent EMF. Now what is the equivalent internal resistance? Look at this equivalent internal resistance R. So 1 by R equals to 1 by 6 plus this is the 1 by 3. So this is the 1 by 2. So R equals to 2. Now this is the current R. Now this is the resistance R. We have to calculate current passed through it. So I equal to, this is the equivalent EMF divided by equivalent internal resistance plus external resistance R. Now look at this is the 10 volt, this is the 2, and R is the 4. Okay, so R is the 4. Look at this. So this is the 10 by 6, that is, this is the 1.67 ampere is the current through resistance R. Okay. Many thanks for watching this video. This video will be extremely helpful for you to tackle the next entrance examination, JEE Main and Advanced. Okay, thank you.